Okay, folks, this is the Chapter 9 homework quiz, and this is problem number 18. All right, so I'm sorry, I had a technical difficulty there. I mentioned this before in the recording that I just did. I want to repeat it just very briefly. Be very careful. Be cautious. You know it's in Chapter 9, so you know that basically the technique you're going to use, but pretend that you don't know, but figure it out. Decide how you are going to proceed without using the fact that it's in Chapter 9, because obviously on an exam that information will not be given to you, and if you're doing this in real life, nobody's going to tell you which formulas to use. You have to figure this out for yourself. Okay, so here we are, Chapter 9, problem number 18. Let me pause this for a second. Okay, so here's the problem. Salaries of chemists. A random sample of 12 chemists, so N is equal to 12 for the first group, this is for Washington State, and it gives you a certain average salary. It gives you a standard deviation. And then for the other group, 26 chemists from New Mexico has certain information. And then the question is there a significant difference between the two states in chemical salaries? And we're going to use an alpha of 0.02. Okay, and we're going to find the 98% confidence interval of the differences in the means. Okay, as always, my strong recommendation is that you follow a certain format. If you do this, it'll at least give you some confidence that you know how to get started, right? So you write down what it is that you're given. You're given certain information. There's two groups, group number 1, group number 2, and then you write down the information. That just comes right from the problem. Okay, so you do that, you write that down. Okay, then you go to the call of the question. What is the question that they're asking you to solve, so to speak? Is there a significant difference between the salaries? And we're going to have a certain alpha level. And then we also, after we do that, after we figure out if there's a significant difference, we say, okay, what is the 98% confidence interval of the difference in means? Okay. All right, so here's my little discussion. As I've said before, it's very, very helpful. Write things out, a little bit of an explanation. It will help you later. It forces you to understand things better if you can articulate exactly what you're doing. If you cannot do that, if you cannot summarize, if you cannot explain what is going on and why you're doing certain things, you really don't understand it. All you're doing is just plugging numbers into formulas, and that's not good enough. So here's my discussion. We do not know the population variances. We know the sample variances. We are comparing two means. Therefore, we're going to use the t-test. Okay, now, how do I know that? Well, I know it because I've studied this and I know, how we do it. Okay, so let's take a look here. Okay, I know that if I'm comparing two means, I'm using Chapter 9 formulas. Here's the important formulas from Chapter 9. This is just from the book. Obviously, you don't have to memorize these. Hang on one second. There we go. All right. So the only issue is, do we know? So we know we're in Chapter 9, and the only issue is, do we know the standard deviations of the two populations, or do we not? So that's why I wrote here in my discussion, we do not know the population variances. We know the sample variances, but not the population. And we're comparing the two means, therefore we're going to use the t-test. Now that comes right from the formula. Okay, here's the z-test. That's where you know the population variances. And then if you do not know the population variances, then you use the t-test. So here it is. I'm not going to read it to you for obvious reasons, but take my advice, folks. Take my advice on this. If I'm lying, I'm dying. Write down the formulas every single time. I always do. Okay, so we need the critical value. First thing we need is the critical values. Okay, so the critical values we're going to get from the tables. Our null hypothesis is that the two mu's, mu1 and mu2, so mu1 and mu2, come back up here, mu1 is the population mean for Washington State, and mu2 is population mean for New Mexico State. Okay, all right. We don't know what the mu's are. all we have is the X bars, okay? But we want to know, is there a significant difference between the mu's or not? And all we can do is base our decision on the samples. Okay, so let's bounce down here. So that's my null hypothesis. What we're saying is that the average, hold on one second. Now, I wrote this, that's my handwriting, but I'm kind of sorry I wrote it that way. It says the average population of salaries for each state are equal. I guess I should have, what I was trying to say there is that the average of the populations, okay? So the mu of the salaries for each state are equal. I'm not too crazy about the way I wrote that. I apologize. Okay, so that's my null hypothesis. Mu1 is equal to mu2. My alternative hypothesis, my H sub 1 is that mu1 is not equal to mu2. And so my research hypothesis is that the average salaries are not equal. And here's my alpha, 0.02. We're going to use table F. Now, the way this works is that the degree of freedom is the smaller of the two. So N1 take away 1 and N2 take away 1, okay? So N1 take away 1 is smaller than N2 take away 1. Why? Because go back up here, N1 is 12, N2 is 26. So obviously this is a smaller guy. Okay, so here's the table. I made a copy of it and put it at the end of the problem. Okay. So we're going to use this degree of freedom of 11. So this column is the degree of freedom. We're going to use 11 because that's the smaller of the two. And then the row that we're going to use is this row right here. Okay. And then which one of these guys over here do we pick? Well, take a look right up here. It tells you. See, confidence intervals is up here. One-tailed alpha, two-tailed alpha is here. It's a two-tailed test because all we're saying is that they're not the same. Okay, go back up here. If we go back up here to the null hypothesis is that they're equal. The research hypothesis is that they are not equal. So whenever you have something that says they're not equal, then it's a two-tailed test because you could be wrong on either side. Okay, where am I here? Okay, so it's a two-tailed test. There it is, two-tailed test. My budget is 0.02, so this is the guy right here that I want. This is the row that I want. So this column, this row gives me 2.718. So 2.718 is the critical value. Okay, let me get back to that. So the critical value is 2.718. Now this is plus or minus. Remember on these guys here, they're symmetric, okay? The t distribution is symmetric. See how it is? It's symmetric. So you have a two-tailed test. Half of alpha is over here, half of alpha is over here. Okay, but it's symmetric. So that's why if I know that if it's a two-tailed test, once I have this number right here, which is the 2.718, that's positive 2.718, and this is negative 2.718. Okay, so this is my critical area here on these. Okay, all right. Okay, so in any event, we use table F, we find out what the critical value is, and then we draw our cartoon. If I had the power, I would slap you in the next week if you didn't draw these cartoons. Drawing these cartoons is a very critical step. So you draw the cartoon, you put in the critical values, okay, that gives you the picture. As a human being, we visualize these things a lot better than we can say them. So we visualize this and we say, hey, this is my critical value here and here. If my test value ends up in this critical area here, I'm going to reject the null hypothesis. So that's the visualization that you make. Okay, so if our test value ends up in the shaded area, we reject the null hypothesis. All right, what is our test value? Well, we get that from our table, our formulas. Here it is. Please, please, please write down the formula every single time. All right, well, this is kind of a complicated formula. So what I'm going to do, just for my own convenience, is I'm going to do a little dictionary here. I'm going to calculate the various terms individually, just for my own convenience, okay? And then I will plug in to the formula. So here I go. I get all these terms, okay? All right. Mu1 take away mu2, that's from right here. Well, by the hypothesis, mu1 is equal to mu2, so mu1 take away mu2 is equal to 0. So that's easy enough. This over this, I just use the given information. I just plug stuff in. I know what the standard deviation, the variance. I know what the variance is of the first group. I know what the variance is of the second group, so it's easy enough for me to just plug this stuff in. Okay, so here it is. Okay, blah blah blah. I just crank it out and I come up with an answer. Okay. Okay, so it's a little sloppy there, but you get the idea. So the variance of group 1 divided by the n sub 1 is this. Okay. Okay, same thing applies here. You crank it out and you come up with an answer. Okay, now where people make the mistakes on this, in my opinion, one of the biggest mistakes, the most common mistake is they forget that what the problem gave us was the variance. Hold on one second. Okay, sorry. So the problem gives us the standard deviation. See, there it is, S sub 1, S sub 2. The formula, however, does not call for the standard deviation. The formula uses the variance. So when you plug it in right here, it's the variance. That's why here it has to be, the standard deviation has to be squared to give you the variance. Okay, so you get I hope you get the concept there. All right, so you plug all this stuff in, okay, add all this stuff up. It's a big pain in the neck. That's why I'm doing it on a separate piece of paper. I have my little dictionary for each of these terms. So now I get exactly what I need for each of the things I'm going to plug in. So now we can plug into the formula for the test value. There it is. Everything gets plugged in. Everything gets plugged in. Obviously, if you're trying to copy this, you're going to have to pause the video. Okay, and so T equals this. Roughly speaking, 9.8. 9.8 is the test value. Okay, let's look at our cartoon again. Here's our cartoon. 9.8 is way the heck over here, way over here. So it's clearly past the critical value. Therefore, we reject the null hypothesis. It far exceeds it. We reject the null hypothesis. There is enough evidence to claim that there is a statistically significant difference between them. Okay, now for confidence interval. Okay, I don't have time to find it in the book. You just got to find it yourself. I think it's chapter 7. Here's the formula. The formula is that this is delta here. Delta means difference. The difference between mu1 and mu2, this mu1 take away mu2, that's the parameter we're trying to estimate it. It's between our point estimate plus the margin of error, and over here it's our point estimate subtract the margin of error. So the margin of error is this. That comes from the formula. Okay. Well, we already calculated that. So we're in pretty good shape here. We know from before what this guy is. Okay. All right. So we can easily calculate the margin of error. And so here's our interval. The interval is our point estimate, which is a 9.205. The point estimate, remember, that's just the x bar, take away the x bar, the two x bars subtracted. Okay. And so that gives us 9,205. Here's our margin of error plus and minus our margin of error. Okay, so boom, there it is, 6,653, yeah, blah, 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 blah. Okay, I'm not really good at numbers. Okay, so, here it is, so approximately it's this. Okay, and that we just round it off. Okay, so I hope that helps. That's how you do this kind of a problem.